Hey, welcome to Dr. Pat TV. We're looking at the part two of rates of change. Now we'll look at the symbolic, work those formulas, work those functions. Okay, so just a reminder, when we're playing with rates of change, we're really talking about slopes. Slopes, rates of change, they're basically the same idea, just a different phrasing for it. Now, you may recall slope is the same thing as y2 minus y1 over x2 minus x1. So you may recall that. Now, if we're going to put this in terms of functions, we're going to basically use that function notation f parentheses x2. Well, that's just another more official way of saying y2. So this is the y value that we calculate from the formula for that second point. And then this is the y value that we calculate from this function using the beginning point, the first x value, I should say, not point, but the first x value. Okay, so now what I want to do is kind of do these quick little calculations here, answer these three statements here. So the first one, what we want to do is find the average rate of change over the interval 2 to 5. Just a reminder, when we're talking about intervals, these, the 2 and the 5, are both x values. These are not data points where it's an x and y. This is the beginning x value. This is the ending x value. This is x1 right here. This is x2. Okay, so that's what we want to be careful about. Also, we want to find the average rate of change at x equals 4 with an interval of 3. Oh, wait, what's my second x value? I got a starting x. What's my ending x? Well, if you want to do that, we're going to have to figure out how we use the interval of 3. That's going to be important. And then the next one we're going to do is find an overall rate of change at x equals 6. And you might be going like, dude, wait a minute. That's only one x value. What's my other x value? Well, one of the key phrases or key words there is overall, and we'll talk about that when we get to it. Okay, let's take a look at that first one. We're looking for that average rate of change. We've been given an interval. Again, those are our x values. So I just, there's my x2 is 5, my x1 is 2. And so I just put those in. And now what we want to do is take that 5 right there, bring it to the formula, plug it in there for the x, crunch it out. That's 5 squared times 11 minus 7. And that's where this 268 came from. So that's what I did the calculation, brought it to my formula. And then the next thing we do is we take this 2 here. We go back to the f function where we see the x, we plug it in. 2 squared is 4. 4 times 11 minus 7. We bring that answer down here, and that's where I'm getting the 37. All right, so now what we've done is we've calculated the y values, and we're ready to calculate this slope. Take the differences of the y's, take the differences of the x's, and then reduce it. Calculate it out. I got a 77. 77 is my rate of change. 77 is my slope. 77 is delta y over delta x, if you want to use that notation. Delta is just a way to say change. So change of y, change of x's, and it's a fraction. It's a ratio. Okay, that's that first example. Let's go to the second example. This time we have an average rate of change. Once again, this phrase right here is just meaning slope between 2 points. Okay, so between 2 points, that's what we're calculating here. That's what the average is telling me. It's between 2 points that we can see clearly. All right, but we've only got the first point. It's x equals 4. Where's my second point? Well, we have an interval of 3. Well, the interval of 3 is another way of saying that's my change of x's. Change of x is 3. So if I'm starting here with 4 and I've got a change of 3, then my next x value right here would be 4 plus 3. This is an x value of 7. So we're technically going from 4 to 7, but it was said the information we were given was slightly different. It was given to us in terms of the first x value and the change, the interval. All right, well, once again, we're just going to take that 7, plug it into this calculation, square it times 11 minus 7, and that's where you're seeing this 532 is coming from. Take 4, go in there, square it. 16 times 11 minus 7, and that's where hopefully I get a 169. And so again, take the difference of that, divide by 3, and I've got a slope of 121. Okay, so when we're playing this slope, this rate of change idea, and we've got a function, all we're doing is just the extra steps of taking that x value that we have right there and bringing it back to the formula to plug in to evaluate, so that way we can continue on with our fraction. All right, then we got the next one going on. Okay, so on this one, recall that, oh, wait a minute. Oh, notice I changed the wording on this. See, originally this was said the overall rate at x equals 6. Well, overall automatically means you're starting here at x equals 0. You're starting at the initial value. And so that's why I'm now saying x equals 0 to x equals 6 is because that's what we do for an overall average rate of change. Okay, so that just means we're starting here. There's my starting x value. Here's my ending x value, 6. Take each of those x values, go to the function, plug them in, calculate, get a result, and let's bring them down here. And then do our calculations. And I get a 396 over 6, which is wrapped up at a 66, and there's my slope. So there are basically our function notation for finding rates of change. Just to keep in mind, it is the same thing as slope. It's the same thing as y2 minus y1 if you're more comfortable with this, x2 minus x1. And this is just the formal notation for saying y2. This is the formal notation for saying y1. Okay, hopefully this was helpful. Talk to you later. Take care.